Question 15. Recall Pascal's principle and apply Pascal's principle to hydraulic systems to solve problems. Pascal's principle states that any change in pressure applied at any point in a fluid is transferred throughout the fluid undiminished. معناته إنه إذا طبقت ضغط في أي نقطة في مائع ما فإن هذا الضغط ينتقل خلال المائع غير منقوص. The hydraulic lift is an application of Pascal's principle. This is called the hydraulic lift, where a small force is applied on the small piston This is called a piston, MacBus, and you can see that it has a smaller area. And as a result, the force applies pressure, and this pressure travels to the other piston, the bigger one, and it exerts a force on the object placed on it. So in this piston, the bigger one, we place objects that we need to lift. So here we have a bigger force yield from the bigger piston. And we usually lift objects on this piston. Now the force applied on a small piston can be magnified, so F2 here is bigger, can be magnified by the ratio of the areas of the pistons. So if the pressure P2 is equal to P1 because the pressure travels throughout the fluid undiminished, if you remember that the pressure is equal to F divided by A, so P2 is F2 over A2. The force yield from the second piston divided by the area of the second piston equals to P1, which is F1 over A1, which is the force applied on the smaller piston divided by the area of the smaller piston. Now, if you rearrange this equation, you can find the force that the bigger force, or the force we get from this hydraulic lift by multiplying by A2 for both sides. If I multiply both sides by A2, then A2 and A2 here will cancel. F2 is equal to A2 divided by A1, which is the ratio of the areas, multiplied by the applied force on a small piston. So F2 is equal to the ratio of the areas multiplied by F1. Alright, let's solve some questions. The diagram below shows a hydraulic lift. What is the area of the large piston? He wants me to find the larger area, or A2. Here I have F1, which is the smaller force. We have F2, the bigger force, and we have A1, the smaller area. Then we're going to use the equation F2 equals A2 over A1 multiplied by F1. You might also see the equation in this form. Whether you substitute in the first form or the second one, it's going to give you the same answer. So 3,000 or 30,000 equals to A2, which is the unknown, over A1, which is 6 centimeters squared, multiplied by F1, which is 30,000 newtons. Using the calculator, 30,000 equals fraction. We have A2, which is x, divided by 6 multiplied by 30,000. You can say that the 30,000 is in the numerator next to x is the same thing. Shift calc and then equal. You see that the answer is 6. Oh, 1 minute. Here we made a mistake. The force of 1 is 50 newtons. Using the calculator again, we're going to fix that, put 50, which is the force on the smaller piston. Shift, calc, and equal. That's going to give you A2 of 3,600 centimeters squared. You can turn it into meters squared by dividing over 10,000. 1, 2, 3, 4. In the hydraulic system shown in the figure, the pressure on the smaller piston P1 is P1 and the pressure on the larger piston is P2. According to Pascal, which of the following is correct? Well, the pressure travels undiminished, so P1 is equal to P2. Here are some other questions that you can look at. Right. Thank you so much.